Welcome to the DX Today podcast, your daily deep dive into the AI ecosystem. I'm Chris, and joining me as always is Laura.
Great to be here, Chris, because today is a genuinely seismic day for the AI ecosystem, and most people watching the news cycle have only seen the headline, not the second half of the chessboard.
Set the scene for everyone, because Jensen Huang took the GTC Taipei stage today and walked through what he is calling the last computer science breakthrough, which is a pretty big claim even from him.
He really did, and I want to be fair here, this was not vintage Jensen hype, because he shipped two completely new processors in the same keynote, one for your laptop and one for the most ambitious AI labs in the world.
Let us anchor on the laptop side first, because for most listeners, that is the part that lands closest to home. So walk us through RTX Spark and why it actually matters to a working professional this fall.
RTX Spark is a Grace Blackwell superchip purpose-built for laptops and small desktops. And the headline spec is that it can run a 200 billion parameter model entirely on the device with a 1 million token context window.
That is a wild claim to make about a portable machine. So I want to make sure we are not overselling it. Because are we talking flagship workstation territory, or are these meant to be slim consumer laptops?
NVIDIA is explicitly positioning these as slim, thin, and light Windows machines, and the launch partners are Asus, Dell, HP, Lenovo, Microsoft Surface, and MSI, with Acer and Gigabyte joining the second wave later in the fall.
The Microsoft Surface partnership is the one that jumped out at me, because Microsoft has been swinging hard on Copilot Plus PCs, and now there is going to be a Surface Laptop Ultra with this Grace Blackwell chip inside.
Exactly, and this is the bridge moment for Windows on ARM because for years that platform has had legitimate compatibility issues. And NVIDIA is showing up with both an ARM CPU and an RTX GPU that runs real gaming workloads.
Help me with the silicon part, because that combination is unusual since you said the chip has 20 ARM CPU cores plus a Blackwell GPU with 6,144 CUDA cores on one package.
That is right. 20 Grace cores designed in partnership with MediaTek, a Blackwell GPU with 6,144 CUDA cores, 5th generation Tensor cores with FP4 support, and 1 petaflop of AI compute at FP4 precision.
And then there is the memory story, which I think might actually be the most underrated piece of the entire announcement, because unified memory at this scale is what unlocks the on-device agent use case for laptops.
128 gigabytes of LPDDR5X unified memory at 300 gigabytes per second, shared between the CPU and the GPU, which means the AI model and the application are looking at the same address space without copies.
That last point is the one I want to land on for a second, because copy overhead between system memory and GPU memory has been the silent killer of agent performance for years on conventional gaming laptops.
It really has, and once you let the agent inspect the screen, the documents in memory, and the model waits all at once without a serialization step, suddenly the local agent stops feeling like a chat box.
So that is the consumer side of the story. And now let us flip to the other half of today's announcement, because Vera is the chip nobody outside the hyperscaler world was really tracking before this morning.
Vera is NVIDIA's first internally designed general-purpose CPU shipping at scale, and Jensen called it the CPU for AI agents, which sounds like marketing, but the architecture choices are extremely specific to that workload shape.
Break down what a CPU for AI agents even means for our listeners. Because to most people, a CPU is a CPU, and the GPU is the part that does the heavy lifting on anything touching a neural network.
The orchestration layer is the part nobody talks about, and as agentic workloads have scaled, the host CPU has become the bottleneck for tool calls, memory management, scheduling, and the reinforcement learning loop sitting around the model.
So Vera is basically a CPU designed to feed the agent rather than a CPU designed to feed a database or a web server, which is a meaningful philosophical departure from how x86 was historically optimized for workloads.
That is exactly the framing. And the numbers are striking: 88 Olympus cores per chip, 1.2 terabytes per second of memory bandwidth, and NVIDIA claims 1.8 times faster task completion than comparable x86 systems.
Per core performance is up around 50% under full load against earlier comparable designs, which suggests they did the careful, boring work on cache hierarchy and memory subsystem and not just thrown more cores at the problem.
Right, and that part matters because cache misses kill agent latency. And an agent that pauses for 200 milliseconds between tool calls feels broken, even if the underlying model is brilliant at reasoning about the task itself.
Talk to me about the customer list, because the rollout NVIDIA published today reads like a who's who of the frontier model labs and is honestly a little surprising in how concentrated it is across just a few names.
The first Vera CPUs were physically delivered last Friday to Anthropic in San Francisco, OpenAI in Mission Bay, and SpaceXAI in Palo Alto, followed by a Monday delivery to Oracle Cloud Infrastructure in Santa Clara.
And then the second wave names include ByteDance and CoreWeave, which means 3 of the top model labs and 2 of the most aggressive compute buyers in the world are all standardizing on this same host CPU.
That is a meaningful concentration of demand, and it tells you that the agentic workload shape is now common enough across labs that they are all willing to bet their next data center build-out on the same architecture.
There's also a really interesting strategic angle here, because Anthropic and OpenAI compete fiercely with each other, and they are both willing to be early adopters of the same NVIDIA roadmap, which is not a coincidence.
It is not, and what it tells me is that the bottleneck has shifted from training compute to inference orchestration, which is the part you cannot solve with just more H or B series GPUs sitting in a rack.
Let us bring Jensen's last computer science breakthrough comment back into the conversation, because that is a wild thing to say out loud, and I want to know whether you think the claim has any merit at all.
I think the literal claim is overstated, but the underlying intuition is real, which is that we have spent 40 years optimizing CPUs around a single-threaded request-response model, and agents are fundamentally a different workload shape.
That is fair, and I would add that the era when general-purpose computing meant whatever Intel and AMD wanted it to mean is clearly ending, because now you have NVIDIA, Apple, Amazon, and Google all designing custom silicon.
And the part of that trend that gets underappreciated is software, because every one of those custom CPUs comes paired with a software stack that locks customers in, and Vera ships with NVIDIA's full agent runtime out of the box.
So when an Anthropic or an OpenAI standardizes on Vera, they are not just buying a chip. They are buying into a runtime, a scheduler, and probably a set of debugging tools that make migration off NVIDIA extremely painful.
That is the moat in plain sight, and it is the same playbook NVIDIA ran with CUDA over the last 15 years, except this time the lock-in starts at the host CPU level instead of just the accelerator.
Let us zoom out and talk about what today actually means for the people listening, because most of our audience is not buying a Vera CPU, but a lot of them are going to be using RTX Spark laptops this fall.
The practical near-term implication is that local agents become real. And by that, I mean an agent that can read your screen, write to your files, and use the same model weights as a frontier lab without sending anything to the cloud.
Privacy is the part that is going to sell this to a lot of enterprises, because today the agent story basically requires shipping every keystroke and every document to a remote API, and that is a non-starter for regulated industries.
Exactly. And a laptop that can run a 200 billion parameter model on device with a 1 million token context window means a lawyer can finally let an agent read an entire case file without violating client privilege.
That use case alone justifies the price premium that these machines are going to carry. And I suspect NVIDIA already knows that the legal, healthcare, and financial verticals are going to be the early enterprise buyers later this year.
The pricing has not been disclosed yet, which is the one big gap in today's announcement, but the OEMs are clearly positioning these as premium machines, and you should expect a meaningful jump over current Copilot Plus PC tiers.
Let us talk about the gaming angle for a second, too, because RTX Spark is supposed to be a real gaming chip, not a compromised tablet processor, and that is a big shift from prior Windows on ARM attempts.
NVIDIA is explicitly leaning into the gaming story, and the RTX brand is doing the heavy lifting there. Because consumers know what RTX means, and the Blackwell GPU inside Spark is the same architecture family as the desktop cards.
That is the secret unlock for Windows on ARM. Because every previous attempt died on the rocks of gaming compatibility and graphics performance. And NVIDIA is showing up with a brand and a driver stack that solves both problems.
It also means Microsoft finally has a credible answer to Apple Silicon on the laptop side. Because for the last 5 years, Apple has owned the conversation about long battery life plus serious GPU performance in a thin chassis.
So if we had to summarize today's news in one sentence, it would be that NVIDIA picked the same morning to attack both ends of the Agentic AI stack, the personal device, and the hyperscaler data center.
That is the right framing, and the part that should worry Intel and AMD the most is not the individual product specs, but the fact that NVIDIA is now competing for the same software developers from laptop to data center.
One more question before we wrap, because I want to know what you are watching for over the next 90 days as these products actually start shipping and as customers start running real workloads on them in production.
I am watching three things: RTX Spark pricing when OEMs finally disclose it, Vera benchmark numbers from independent labs and not just NVIDIA's own slides, and any signal that AMD or Intel responds with their own agent-oriented CPU roadmap.
Those are exactly the right things to watch. And I would add a fourth, which is whether the on-device agent experience on Spark actually delivers on the promise once real users get their hands on these machines in October.
That is the right addition, because every NVIDIA keynote spec sheet looks incredible until the third-party reviewers start measuring real-world battery life, thermals, and how the agent feels during a genuinely busy day of meetings.
For now, though, the takeaway is that today was a clean step change in what we should expect from both the laptop and the data center, and the rest of the industry is going to have to respond quickly.
That is right, and if the rollout goes anywhere close to plan, this autumn is going to be the first time most knowledge workers actually have a personal AI agent running locally on their machine all day long.
That's all for today's episode of the DX Today podcast. Thanks for listening, and we'll see you next time.